Hi everyone, my name is Pinjen. Today I want to talk about the associative behavior of the fish cryptotranters, and the pistol shrimp Alpheus gibotensis in artificial barrels. Apple shrimp, the left one is the apple shrimp. Apple shrimp are almost blind, but they are very good at digging holes. And the right one is the guppyfish. The guppyfish needs a shelter, so they go find the guppyfish and live with them. So in the exchange for the shelter, guppy need to be the eye of the shrimp to help them against the predators. So their association is a mutually beneficial partnership that were generally accepted by people. Then why do we still have to do this research? The behavior in the field and in aquarium has been observed many times, but there's no data about the behavior inside the barrel. So our purpose is to record the behavior inside the barrel. This is our material and method. We put one fish and two shrimp into the aquarium, and this is our aquarium environment. The water temperature is 22 degrees, and we put a plastic tube that will cut half along its axis, and we buried it in the sand as the artificial barrel, so we can see what's happening inside the barrel. The following is our result and discussion. The first part is the digging type of the shrimp. This is before introducing the digging type, I have to introduce the body structure of the apple shrimp. This is the apple shrimp, and here is abdomen. Abdomen means the belly of the shrimp, and apple shrimp have two antennae. The first 5 pair of legs are the period part, which is used to walk, and the first 2 pair were specialized into the chele. And the last 5 pair of legs are pleo part, which is used to swim. And there are 3 different digging types of the shrimp. And the first one is the rapid movement of the pleo part with the belly directed toward the entrance of the barrel. In the picture, you can see that the apple shrimp accumulates the sand into a pile, and then it turns around and pushes them out of the barrel. The second one is digging with the first pair of chele. There's a video. This is used to loosen the sand. You can see that he inserts his chele into the sand and pushes it out of the entrance, away from the entrance. The last one is digging with the second pair of chele and the walking legs. This is used to find the food. You can see that. You can see the shrimp use its walking leg to roll around the sand to find the food particles. The next part is the behavior outside the barrel. And when outside the barrel, the shrimp keeps one antenna in contact with the fish, and the fish reacts to the antennal contact by tail. And while antenna maintain contact with the fish, the tail undulation will follow the appearance of the shrimp from the barrel. And so you can know that the antennal contact is the key to transfer the information from guppyfish to apple shrimp. So the antenna can make contact with different parts of the fish's body. And this is the number of the contact in different part of the fish. So you can see that the contact with the tail was more often than contact with the head area. And when outside the barrel, the correlation of the partners has an obvious advantage for the shrimp, but inside the barrel is less apparent. So we think that in the barrel, the dependency of the shrimp on fish is merely a continuation of its behavior outside the barrel. And to investigate the retreat response of the fish and the shrimp, we use a metal rod to approach the animal when they are outside the barrel. And this figure is the mean value of 20 tests. The horizontal axis is the time, and the vertical axis is the different distance from barrel entrance. And below this line means that they are inside the barrel. So you can see that when the stimulation comes, the fish turn into the barrel immediately with head entered first. And in contrast, the shrimp always enter the barrel with tail first. And when they are in the end of the barrel, the fish will turn around in the barrel and begin to move back toward to the entrance again. In this experiment, we also observed that the deeper the shrimp had been inside the barrel, the less it retreated. And in the experiment, we also found that the fish turn head entry into tail entry, and the retreat distance of head entry is much deeper than that of the tail entry, which means that the retreat response to the stimulation decreased in intensity. So what if we remove the fish from the shrimp? The shrimp will drop the sand and the shell fragment at the entrance without coming out. So as the result, the entrance of the berry was almost blocked by the sand. And only when the food was given, the shrimp will leave the barrel. And in the absence of the fish, the approach of the rod has no effect on the shrimp. When the fish came back, the shrimp treats the fish as usual, but fish stayed a longer time in the barrel than before. The cleaning behavior of the fish by the shrimp is recorded in our research observation too. And it is worth to notice that this is the first record of cleaning shrimp in the alphabet. And the shrimp used its second pair of chellae to clean the fish. And this behavior also usually concentrates on the head region, especially around the eyes and the mouth. And the behavior always stops when the fish moves away. The behavior we observe like attending contact, see here, he contact the fish with his antennae. And the digging way of the fish, of the shrimp, like we talked before, can be found in between different species of guppies and the pistol shrimp. And in other studies, they use the fish and the shrimp below this here, and they show very similar associative behavior in the zone. Shows very similar associative behavior compared with our species, the species we use. So our conclusion is we suppose that the associative behavior between the species we use can be generally applied to other gummy fish associated with pistol shrimp. Thank you.